Thank you, everybody, for joining me for this great session. I tell you, we've got a bunch of speakers and a bunch of information to get across. So I don't want to waste any time sitting here talking and taking up their time. I'm going to go ahead and bow out and pass it on to our first presenter. So go ahead, Bryan, take her away.
Thank you very much, Jimmy Ray. It's a pleasure for us to speak with all of you on this topic. I think it's going to be, you'll see as we go through this, it's got some very exciting information. I'm leading our vertical solutions for the Internet of Things and Internet of Everything for the manufacturing vertical. And then I'm going to be followed by Todd Edmunds, who is the manufacturing solution architect. And then Mark is going to take us through the products that he's managing that are critical parts of this solution. So you'll see the agenda that we have today. We're actually starting with the business outcome that you can drive in your factories with the Internet of Things. Then we're going to talk about the enabling solution architecture and platform that you need to achieve those benefits. And then we're going to share with you the products that slot into that architecture. So should be a very interesting and hopefully comprehensive view over the next hour. So the Cisco vision for the Internet of Things is shown on this page, which is we believe the Internet is entering into the next generation. And the first wave of the Internet was the carpeted space, connecting to PCs and laptops. And it's now moving into a new era of connecting to the non-carpeted space. And that's everything from connected vehicles to connected TVs, on the consumer side, to what we think is even possibly more important is connected enterprises. And we believe that just as the first Internet drove significant business value through things like e-commerce and e-fulfillment, in the corporate world, we think as well the Internet of Things, which has been a trend for a number of years but is now really hitting an inflection point and building momentum, we think this Internet of Things transition is going to drive tremendous value in the enterprise space, especially in oil and gas, where you're connecting to oil fields, and to things like connected trains, where you're enabling positive train control, connected cities, et cetera. And another point I would mention is this is not really futures, it's already here today. And just within a few years, we're already going to be up to 50 billion smart objects that are intelligent, connected to the Internet of Things. So on this point of value creation, the Internet of Things is driving in the manufacturing space, by our calculations, $4 trillion of benefits to manufacturing companies over the next 10 years. And that's actually twice as big as the next closest vertical in terms of the impact that the Internet of Things will have on that vertical. And it's going to impact a variety of processes, including accelerating R&D times by up to 35% with greater information, transforming customer experiences and channels and dealers, creating more real-time, high-velocity supply chains, et cetera. But you'll see on this chart that in the plant space, in the factories, 2 trillion of that 4 trillion is going to occur. So that's what we're going to zoom into and talk about more today. And by the way, when we talk about the Internet of Things, it's really connecting to the devices in the factories. And when we talk about the Internet of Everything, it's then connecting all of that new information into people and business processes to ultimately drive the impact on the enterprise. So I'm asked frequently, we're talking about $4 trillion in the Internet of Things, but what exactly is it? As we connect to all of these factories and enable factories of the future, what exactly are we doing? And essentially, we're connecting now to a new array of sensors and robots and machines in the factories, everything from drives to conveyors, as well as security devices and cameras in the factory, personal devices, et cetera. And we're connecting those with some of the products and architectures you're going to hear about in a minute, where we've built ruggedized access points and routers and switches and security that really meet the needs of those factory environments that could be high temperatures and dust and vibration, and even specific industrial protocols that we've built into our architecture architectures. And the net result of that is by connecting to these devices and driving more intelligent information, we're able to significantly improve visibility that leads to lower downtime, faster response, and higher utilization of factory assets, as well as lower cost. And we're going to talk more about, how we're doing that. But the basic idea is we're bringing intelligence and Ethernet standards into the factory and enabling all of these new use cases. I love this quote from the chairman of Daimler that in this decade, the manufacturing industry is going to transform more in the next 10 years than it has in the last century because of these new technologies in large part. And many people are calling this a new industrial renaissance or smart manufacturing, or in Germany they call this Industry 4.0, which is now bringing that intelligence and mobility and these new capabilities into a manufacturing plant that they actually think is driving a new industrial revolution. As big as the steam engine or the birth of automation in terms of the impact that it's going to have on the manufacturing industry. So it's really an exciting time. We're seeing customers that are increasing their overall output by 10% or 50% or even more by leveraging increased automation and some of these new, more intelligent automation systems. So let me share a little bit on some of the value drivers that we're seeing in the industry, taking advantage of the Internet of Things and the solutions that I just talked about a minute ago. And again, we're going to dive deeper into this in a minute with Mark and Todd. But one of the areas, and it's actually the smallest benefit, is lower cost. And we as we move what typically has been very siloed, fragmented networks and factories that have not been connected to the enterprise. As we move those to Ethernet and connect them and converge them, we're able to simplify the plant networking architectures and actually save money. We're working to cut the cable wherever we can in plant environments, and this is really the start of a journey in that area, but you may see tooling, for example, in a manufacturing plant, something as simple as a torque tool, which might be one tool, but you might actually have 3 different cable runs connecting to that tool with multiple NIC cards, and by the way, you might have to move that tool, frequently in between production lines to balance the line and have to recable the whole thing. So there's a significant efficiency gain that we can achieve through moving to these next generation architectures. And we're partnering very heavily with people like Rockwell to achieve that. On the other side, though, the bigger impact is not cutting costs, but actually increasing output. If you look at the U.S. manufacturing capacity, just as an example, we're at 80% right now, which is nearing what is considered full capacity utilization. If you look at the automotive industry, some of the car companies have gone from 40 or 50% utilization a few years ago to 120% utilization, where they're working around the clock, and they've got to anything they can do to get more cars out the door is incredibly valuable for them. So we're seeing these solutions with greater visibility actually impact production. And here's 2 really good examples. On the right, this is a semiconductor company where they did something as simple as tagging key elements of their production process. And by getting that visibility and reducing search time and retrieval time during the production process, they saw a 7% boost in their throughput, which is very significant. And on the left, you see another example where by putting in mobile and wireless in a factory, they achieved 80% faster decision-making, cost savings, and actually a 10% boost in productivity of the operators in that plant so that you could see the information on a mobile device wherever you were versus having to walk in a very large facility to the manufacturing plant to see what was going on. So that's something that's very significant. Plant uptime is another factor that we think is very significant, and for many manufacturers, this is actually the killer app. anything that you can do to reduce unplanned downtime is going straight to their bottom line. As an example, in an automotive plant, 1 minute of downtime is costing them over $20,000, over $1 million per hour. And with the Internet of Things and these new sensors and Ethernet-based standards and converged networks, we can now significantly improve visibility to when there's a problem. We can speed fault isolation. So instead of spending what I heard from one customer recently, 3 or 4 hours when they had an electrical issue trying to root cause where it was, they took that 3 or 4 hours down to literally minutes by their electricians by having this visibility and managed networks from the Internet of Things. And that, again, translates into increased output and significant boost in profitability. In fact, we estimate that each 1% increase in output is actually a 3% boost in profitability of most manufacturers. The case on the right is also very interesting, where we're seeing more manufacturers want to not only connect their machines and get visibility to the machines in the factory, but also be able to securely provide remote access to those machines so that their partners and vendors of those machines who really have the expertise can provide new services like predictive maintenance on those machines and things that can really extend the mean time to repair or rather shorten the mean time to repair and extend the operating life of those machines. And I just came from the IMTS show with 110,000 people in Chicago last week, and FANUC, as an example, was showing how you could securely connect and monitor their robots with new services. Not going to dwell on this one, but this kind of information can also speed responsiveness and accelerate collaboration between the factory personnel and the design engineers, and that can accelerate time to market and the ramp of new production for new products. And we can also, we're seeing impacts of things like reducing engineering changes so that you, with more granular traceability when there's a problem in the factory, you're not guessing at what the problem was, but you're actually able to see in detail the streaming operational data from the robots and the machines. And so if you see a quality issue, you can root cause the source of that quality much faster than you could otherwise. And this example on the right is a manufacturer that's actually estimating they can take the cycle time to make an engineering change when they have a quality issue that's discovered at a customer by a month to, in many cases, less than a day by having this new Internet of Things visibility. So net-net, these are capabilities that we're not talking about just incremental benefits. It's not easy in a manufacturing environment because it does have different operating environments. There's very harsh real-time requirements that we'll talk more about, but the size of the opportunity is very significant. And the architecture that we're going to talk more about is really solving these customer pain points. And we've out of the use cases of everything that's possible, we're really zooming into 4 areas. How do we enable factory automation with greater visibility and increase overall equipment effectiveness? Second, how do we then build on top of that factory wireless so that we can make workers in the factories more productive, but also start to connect to machines and tooling and quality systems in a wireless manner, which, as we've talked about, can have a very significant benefit. And one of the why Cisco's in that is we can offer that unified managed wireless environment where you can manage the RF interference in, again, a very harsh environment to make the wireless systems work for both these operational technology or OT environments as well as IT. And then the third use case we're working on and focused on is factory security. And, this is a quote from a customer that basically had no security in their plants. This had become a board of directors level concern. The board had a task force that was meeting monthly to assess factory security, both to reduce the risk in the factory and improve safety, but also they were worried about threats coming into this unprotected environment, like the Stuxnet attack or the target attack that came through the HVAC monitoring systems, and then spreading from there into the IT environment. So how do we secure the factories as you move to Ethernet and start to enable these new capabilities becomes much more important as well. And then analytics becomes very important. As you get all of this new data, what do you do with it? And so we're very focused on things like energy management and how do you not see your energy use a month later, but how do you get real-time visibility to the machines and facilities and data centers in a factory so that you can real-time react to reduce energy consumption. And that's another area where we're expecting a 10 to 20% minimum savings in energy based on customers that we've been working with. So one key success factor as we go through the rest of this webinar and session is how do we get there? Because I've been talking about some very big value propositions, but why aren't we already there today, and what's holding the industry back? And our view is that the starting point in many factories is these are islands of automation with multiple fragmented networks, many times serial or proprietary networks, and you've got to move to Ethernet to get the richer sensor data. You've got to converge these siloed networks so that you can connect the business applications to the frontline apps or frontline systems. But then you need more than that to really enable factories of the future or smart manufacturing. You need a flexible multi-service platform. And so what you'll see from Todd is we're actually starting with these plant-wide networks and automation, but then we're layering in security and mobility and video and remote monitoring and cloud models and so forth into that integrated architectural platform. And that lets customers, as they decide to turn on new use cases going forward, do that without having to reinvent their network, and so they can do it with much lower cost. Obviously, we're not completely there yet, but you'll hear more from Todd in terms of where we're heading on our journey. And we think these validated designs that we are offering, this is not just PowerPoint, that converged platform, but we've built Cisco and partner validated designs that accelerate time to value and prove that these systems work, and it really addresses some of the top barriers that our customers are saying. For example, in this IDC survey, it's addressing some of the top barriers for them implementing their factories of the future strategies and really improving the operational performance along some of the lines that we've talked about. So with that, enough on the benefits and the why, because of course this is going to vary by customer, and that's one of the things Cisco can do with you is partner with you to help you map out how you can translate this opportunity into bottom line value in your plant. But now let's transition to Todd to talk about what does this mean in the plant and how does our connected factory architecture and the architectures we're building with our partners like Rockwell, how does that enable this to happen?
Great. Thank you, Bryan. This is Todd Edmunds. I'm the manufacturing solution architect for Cisco in the Internet of Things group. And building on what Bryan said and talking about the potential benefits of the IoT and the IoE in the plant floor are huge. The difficulty level of implementing it really is not, and that's because of a converged Ethernet architecture, connected factory architecture that we've developed along with our partner Rockwell Automation. The nice part about it is that you reduce your risk by implementing this because it's a Cisco validated design. It's pre-engineered, ready to go to do that. So it's an architecture that will scale and expand, and we'll kind of get into this a little bit more as we go forward, but it will scale and expand, and that's important because the data from your factories are not decreasing. You've got a manufacturing execution system, you've got predictive maintenance, you've got mobility, and those type of things are exploding, needing more data coming from your factory. So it's important that it scales and expands. This architecture is built on open standards, so you can reduce costs in the support, and it's an end-to-end solution. So Cisco is really the only company that's looking at this holistically across the board. Down at the plant level, the industrial Ethernet switches, traditional Ethernet switches, which is our core business, wireless and networking, security that's wrapped and integrated into all these things that we do, collaboration and communication products, and our compute platforms up at the enterprise level. Again, everything taken into consideration in the development of this architecture from the shop floor all the way to the top floor. So the tool to help you accomplish this is the architecture, and we call it, just like all large companies love their acronyms, we love our acronyms too. CPWE is what we call it, and only Cisco would come up with a 4-letter acronym for a 3-word phrase. So I'm going to take these each one. So converged plant-wide Ethernet, that's what we call it. So CPWE. So starting with the end letter, Ethernet, and Ethernet is relatively new on the plant floor, okay? So there's a mixture of obsolete and proprietary serial protocols, and there is some Ethernet there, and what Ethernet is there is usually installed haphazardly and plugged in with off-the-shelf Best Buy switches, zip-tied to overhead pipes and stuff like that. So the plant needs IT's help, but IT needs the help of the plant too, because while both the plant and the IT side have certain priorities, and those priorities are the same, but they are differing in their order of importance. So at the IT network, obviously confidentiality, security is one of the most important. Integrity and availability are there too. On the OT network side, which is Cisco's word for the plant floor, operational technology, availability, uptime, that's number one, far and away above everything else. Integrity, confidentiality is there. It's important, but not nearly as important as the availability, the uptime of the plant, because the plant is where they generate all their money. It's printing money, and they can't take it down. Another important distinction between the two is the IP addressing scheme. As most people know, the IT side, it's a dynamic scheme, so you assign the IP addresses dynamically. At the plant floor, those all have to be static IP addresses because everything refers to each other in a static method. So there's no DNS server on the plant floor. At the plant, in the manufacturing side, DNS stands for do not stop. So for the middle part of the CPWE, plant-wide, make no mistake, there are more nodes in the plant and the rest of the plant than the rest of the office. And that includes the entire plant, all the way down to the plant floor, the manufacturing zone. So we got some more acronyms here. So controls, that's the heart, the brain of what's going on the plant floor. PLCs, programmable logic controllers, they call them, sometimes called PACs, programmable automation controllers. Operator interfaces, more acronyms. HMI, which is human-machine interface or operator workstations. You've got inputs and outputs that actually do the real work on the floor. Motor controllers, cameras, wireless devices. All these are endpoints that need to be connected and integrated into the network. The remaining letter is C for converged. So connecting the plant and the enterprise together to get that data out of the plant floor. Now the plant really doesn't want IT on the network, and usually the IT does not want the plant on their network either. But if you've lived through the integration on the IT side of VoIP, and everybody said that same thing, it's very, very similar. Those networks can play together and can reside together and get the data. How do we do that? Well, when we built this architecture, we enlisted the help, and they enlisted our help, I guess is the way to say it too, of Rockwell Automation. So Rockwell Automation in North America is the company to partner with. They know the plant floor and the automation side of it. So in combination with them, we developed Cisco CVDs, a Cisco validated design that makes the IT side comfortable with how this all connects together and how it puts together. So another way we address the challenges of connecting these are through our products. And my colleague Mark will talk a little bit more about these as we go forward, but we've created products that fit into this architecture at all. The Cisco switches, so we've got the best of Cisco iOS, and the best of Rockwell Automation, which is plant floor hardware with Common Industrial Protocol, which is their protocol that rides on standard unmodified Ethernet, and we've built that and other helpful things into the switch line to make it easier to implement this type of architecture, this type of a solution. So the other thing, the architecture is also built on open standards. So it's built on standards like ISA 1000, also with an ISA 99, but also with built with open protocols from ODVA, so the Open Device Vendors Association. The foundation of that, too, is based on the Purdue model. And the Purdue model divides your network up into zones. So the top layer, the enterprise zone, is where the IT stuff happens and all the PCs and data centers are. And we call that enterprise zone or level 4 and 5. The next zone is the manufacturing zone. And if you notice I skipped one, we'll get back to that. But the manufacturing zone is level 3. That's where the manufacturing software resides. So in Rockwell terms, that's factory talk servers and that type of stuff. So things like historians or operator interface server that serves up the touchscreens down on the plant floor, asset management things, those sit in the manufacturing zone, as well as things like Cisco distribution switches, so a 3750 stack-wise switch, for example, but also the core that connects it back up to the enterprise zone, core switches like the 4500 and the 6500. So the next zone down is the cell area zone. This is actually where the machines and the plants and the controls are. These are the components that make the factory actually run. So again, PLCs, HMIs, I/O, the drives, and factory floor PCs. So the CPWE, Converged Plant-Wide Ethernet model, also introduces another zone to provide kind of an insulation between the enterprise and the manufacturing side. This is where applications like the firewall and terminal services and patch management things reside. Sometimes we call it layer 3.5. Sometimes we call it DMZ or IDMZ just because we wanted to add more acronyms in there, Industrial Demilitarized Zone. So then if we take all of these Purdue model, and taken as a whole, we can map that to the Cisco validated architecture for the connected factory. Again, your enterprise network up at the top level with a demilitarized zone, firewalls in the middle, manufacturing zone where the applications reside, and then down at the plant level, different topologies that we can connect in and connect the different components that live on the factory floor. So some of those topologies are high availability rep ring protocol, which is shown in the middle at the bottom there. We've got redundant switch connections over to the left, and also linear topologies. So the message that we have here is that with this architecture, we can deploy and support and converge networks that are normally complex and time-consuming, but we can take that complexity out of it because we've got a validated and documented design guide. There's more information at the very end of this. There are some links, and you can go there and look up Converged Plant-Wide Ethernet Design and Implementation Guide. It's a 400-page document. Some people call it the Industrial Networking Bible. Great resource to answers all those questions. And so we have and in addition, an end-to-end portfolio. So you're not just sticking different parts and pieces out there and hoping that they end up working together and do it in a scalable and secure way. So again, get this next slide. Again, we have a common architecture, ruggedized for the manufacturing, industrial side of things, all the way up, end-to-end architecture, supporting everything all the way through that work together, that has a common security backbone and framework. We're connecting the business applications to industrial systems, and it's all based on and leveraging industrial IP Ethernet switching protocols that are open protocols. And so, and we're continuously expanding these capabilities. We're continuously expanding what we're adding to it, the testing that goes along with it. And our next release, which is coming out in November, is going to include wireless. So we're going to add things like wireless I/O, wireless control, wireless controller-to-controller communications, but we're also having a unified and an autonomous version. So you can have just a standalone wireless access point, or you can have it a wireless LAN controller. And that's all going to be built into this architecture, all available to be leveraged by doing this in the future. And then speaking of the future, coming up in the upcoming releases of this, like I said, we're going to be integrating security even deeper in. So we're adding in identity services. We're going to be adding in guest access. So if you have a contractor come in from the outside and they need to do some work, you'll be able to give them access for a certain amount of time, accessing a certain asset for a certain purpose. We're going to have remote access, so you can call on remote experts that can call in over the internet and fix things remotely. But in addition, some of the newer protocols like device level ring, that'll be integrated into new switching platforms. And again, Mark will talk about that here in just a minute, but including video and collaboration. So that's the kind of the overview of the architecture. Mark will get into a little bit more of the details of the switches. Have any questions, please post them. Be happy to answer them, and I'll hand it over to Mark right now.
Thank you very much. Okay, so I'm going to talk about the Industrial Ethernet product portfolio and talk about the features and functionality of the switch line we have that I'm managing here at Cisco. So this is a full snapshot of the family line. We have from access to aggregation, starting from the left, the IE2000 series switches and the various form factors we have there I'll talk about in a minute. And we also have a cousin, the IE2000U, with the U referring to utilities. Todd spoke about this a bit briefly, but essentially the differences between the two is the fact that we focus the IE2000 on the plant floor and in discrete manufacturing, and there's certain industrial Ethernet protocols that are being used there. Whereas for the IE2000U, there's specific functionality and requirements we must sustain in the utility space. For example, one would be the PRP capability, parallel redundancy protocol. Next, we have the IE3000, which is a modular switch, and we have various form factors that can meet that in the sense that you can add modules, you can add PoE capability. Next to that is the IE3010, which is a one rack U unit, will provide you two capabilities in the sense that you have two SKUs, one with 32-port copper, and we also have the capability of doing PoE in another one. Its cousin is a CGS, which stands for the Connected Grid Switch, which is the 2520, which would also be used in conjunction, for example, with the 2000U in the utility space. That covers the current commercially available product portfolio that we have. In 2 months, we will have the IE4000, sorry, 3 months, the IE4000 that comes out. The main difference here is the IE4000 now is a full gigabit switch capability switch. So the IE2000, which does 10/100 and for the downlinks and has gigabit for uplinks, the IE4000 on the other hand will have gigabit for the downlinks and uplinks, which I'll talk in a bit more detail in terms of uplinks and downlinks and what that refers to. Last but not least, the IE5000 is going to be sort of the larger brother to the IE3010, a one rack U unit, and this will be also full gigabit capability, full gigabit capable switch. And so let's look into a few more of the details of the capabilities of each of these switches. I should also mention that compliance is very critical to conform to in this industry as in the plant floor, and clearly we abide by. This is a subset of the standards that we abide to. At the very end of the presentation, there will be links for each of the switch portfolios, and in there you'll have a longer list of the standards that we comply with, which is probably critical to mix and or meet in your environment. Excuse me. So starting off with the IE2000, there are essentially three categories: 4-port, 8-port, and 16-port. Within one of the three categories, the 4-port, you'll have an option of doing all copper on the very left, or you can do SFPs, which is the second to the left. This obviously will provide you much more distance if that is needed. in some floors or some environments, distance is critical. So you have to go beyond the standard 100 meters, standard 100 meters of copper Ethernet. You can get distance up to 40 kilometers, and even we're coming out with 80 kilometers later this year. The 8 ports provides more ports, and just to briefly talk about this, the 8 ports is, when I say 4 and 8 ports, I'm referring to the top section, and the bottom 2 ports, this is a combo port, will either give you SFP or copper. It's up to the customer to choose which one they would like, and again, that basically will come down to the distances that they require. The third category, the 16 ports, has a few unique capabilities to it. The first one that customers are drawn to is the PoE capability. For the i2000, the 16 ports, 4 of the 16 ports, if you look at the model on the very right, the left 4 ports are the ones that will provide power over Ethernet, and this is critical for example, providing cameras, power, and so on and so forth. So this is just a quick snapshot of the various form factors we have for the IE2000 switches, and we can take a closer look here, and I'll just touch upon some of the unique aspects of the switches in the discrete manufacturing space. They're all based essentially on the Catalyst platform, but we have to add ruggedization and do a few unique aspects here so that they can be used in discrete manufacturing. The first and foremost is that we've noticed that the environment typically will have 24 volts. So the voltage, DC voltage inputs here on the right are something that is quite unique to this switch platform. So you have that in the green. The next piece here is the bottom right-hand side is a draw contact alarm. This, we will have customers integrate that with, for example, alarm lights, where they can go through the various colors so that operators will know whether that everything is functioning either properly or not properly. And if not so, then quickly they would typically aim to replace the switch physically. The downlink ports I just referred to are, again, the top left here, and these would plug into, for example, the PLCs or IOs or servos that a platform may have. And the uplink ports on the bottom left are the combo ports. You can either get the copper or the SFP type. As well as one critical function that we have for these switches is the SD flash. SD flash socket, which you'll see in the middle bottom section here, is important because this will contain the iOS image as well as the configuration file. So if for instance, we talk about a failure that needs to be that is notified, let's say alarm goes red and then the switch has experiencing failure, we will see customers quickly remove the switch itself, replace it with a brand new one, take out the SD flash, and replace it into the new unit and boot it up. By doing that, you can essentially avoid having to spend time on what can be tricky network issues and bring up your infrastructure in a relatively quick speeds. In some instances, we've been quoted by customers that they were able to replace essentially a switch and power everything up within a matter of minutes, and they very much appreciate this capability that this switch has. I spoke to the PoE, and there's a few things I just want to mention here when we talk about the PoE ports. The 16 port, first of all, the i2000, in the i2000 series, it's the 16 port switch is the one that has these PoE ports, and they are, again, on the very left here, the 4 in the red square. These PoE ports can do a few things. So PoE really refers to providing an end device like a camera, 15.4 watts. But we also are able to do PoE Plus, which is providing 30 watts from the switch itself to maybe a more of a power-hungry camera or a card reader or things of that nature. So that will be 4 PoE ports. One thing we want to make sure everyone understands when you purchase this unit is that there is a separate power supply on the bottom left here that it connects to the switch itself, and that power supply is used to draw, to pull or draw power to the switch itself, or the PoE ports, sorry. So there's a separate power unit that is used for the PoE ports, and on the right is the power inputs for the actual switch frame. Unique capability that we have in the IE2000, and this is something that we've won some awards on, is the capability of doing layer 2 NAT. It can get very complicated quickly to explain some of the details, but essentially, if you're running a plant floor and you have PLCs in the, let's say, bottom mid-section or the lower right section here, a lot of the PLCs or HMIs might be provided with the same IP address. For example, you could see 192.168.1.1, and the HMI has 1.2, and over this is sort of drawn out and built out on the factory floor. In that instance, it can be rather tedious and cumbersome if you need to get individual people to go out and program different IP addresses or different subnets in this case for these various machine floors. To overcome this struggle, we have built in the layer 2 NAT capability where you can configure the switch to be able to fool, for maybe lack of a better word, a end PLC or HMI from talking from, let's say, machine 1 section 1.1.192.168.1.1 to machine 2 PLC 192.168.1.1. So it'll think it's speaking to a different subnet, but in fact the switch itself is able to do NAT capability and translate that communication, so everything runs relatively smoothly. So this is won an award, Control Engineering, this year actually, so we're rather proud of that. It did come up as a Stratix 5700. Todd did talk about how that we have a very close partnership with Rockwell Automation, and they resell the IE2000 switch as a Stratix 5700. So essentially, you can interchange the names. There are a little more unique capabilities in the Stratix 5700 in the sense of integrating with other Rockwell devices and speaking CIP protocol. However, the NAT capability is available in both the Stratix 5700 as well as the IE2000 switch. Here's a quick introduction of more ruggedization in the IE2000 family. We have an IP67 version of this switch, and there are 5 SKUs to this. There's 2 that are either PoE capable and do gigabit uplinks, the 8-port or 16-port version, and these 2 selections you can do, with the 8-port you can do 4-port PoE, or with the 16-port you can do up to 8-port PoE. So there's 4-port PoE in the 8-port IP67, and there's 8-port PoE capability in the 16-port 67. Other than that, there's a power supply that is also ruggedized, IP67, which is used to essentially work in an environment that I referred to before, which may operate at 24 volts, and yet the customer wants to use PoE. What they would do is they would plug the power supply into their source with the 24 volts and upgrade or step up the voltage to the switch itself up to between 54 and 57 volts to provide the necessary wattage to power components that, for example, a camera that might plug into the 67 switch. The IP refers to intrusion protection. 6 is one of the higher levels of dust, so larger specks of dust. 7 is refers to the water and how much, up to what grade of water you can get into. And as an example, we have put in an aquarium, but technically what this really is within 1 meter or 3 feet approximately, you can place a switch for about an hour, and that's what the spec calls out for, and we have to conform to. Next is the IE3000. This is a modular switch we have. This is one key attribute to this that customers like is they may build out their network slowly. So what they do is they will get a base unit, as either maybe a 4-port or 8-port base unit. And as the network grows, they can add modules. Or if they want to add more cameras, again, or card readers or anything that needs PoE, you can add a module that provides PoE. That'll be the bottom in the middle section, the bottom 2, the IEM3000 4PC or the IEM3000 4PC 4TC. That'll be 4 PoE ports or 4 PoE ports plus 4 twisted copper ports. And you can add up to 2 modules. So an example would be having a base unit with, let's say, 4 ports, adding a 8-port module, and then on top of that, adding maybe an 8-port module with SFP, giving you a base unit and 2 modules. So this is a mix and match that you can do, and you basically can power the base units with the 50-watt power supplies that we provide, and the PoE modules you must power with typically the 65-watt power modules that we have. Following the 3010, the one rack unit switch, you have 2 flavors, either full copper for copper-rich environments where there's many, for example, maybe PLCs or IOs or what have you, and then you also have the capability of doing fiber for the other SKU as well as PoE. So if you have a fiber and PoE environment, I recommend the IE3010 16S APC, which is the lower one of the 2. All of these switches I referred to come with a web device manager, which I think both Todd and Bryan referred to. In these environments, sometimes it may be difficult to find skilled workers or those that understand IP technology and to a depth that really isn't part of their core skill set. They may be tools engineers or engineers that are focusing on building out on the plant floor some maybe car doors or what have you. So for that, we try to make ease of use a prime theme in our development of the switches, and there is a GUI manager that you can utilize, which will give you essentially the understanding of the health of the switch, what ports are up, what is not being used, what is being used, the temperature that they're operating at, as well as you have the capability of selecting a port, and if a phone, for example, is plugged into a PoE port, you can select a common configuration for the quality of service settings for that port. So there's this capability of doing that through the GUI, which we highly recommend. Referred to in the IE2000, the SD card, we also have the zero config capability in the IE3000 through the swap drive, which is another section that customers appreciate very much, is having the OS or the configuration in the drive, in the swap drive, the bottom left section, and quickly inserting that and configuring the switches. In fact, technically you could use a swap drive with multiple configurations and go over maybe 10 or 15 switches and do the configuration accordingly. So these quick to boot, quick to configure, and quick to run is some of the features that we are proud to bring. For more information, we have the following web pages. On the IoT is the top page, and then manufacturing. And then for the 3000 and 2000, we have the IE3000, IE2000, and for the 3010. And as I talked about in the first slide, there's the 4000, which you'll see in the December timeframe. So that'll be the full gigabit switch, and our 5000, which we are targeting mid of next year, calendar year in 2015. So please stay tuned for that. And thank you very much for your time and hearing out our capabilities in the industrial Ethernet switching portfolio.
All right, thank you so much. Really good stuff, and a lot of good material there for IoT. Now, hey guys, we've got about a few minutes left here. Do you guys mind if I ask you a question real quick on, while you're going through this, something that was kind of making me wonder a little bit? What are we looking at here for automation on all this type of stuff? Because I know that in a lot of the factories I visit, that's a really big deal.
We're adding features like the SIP protocol to the switches to enable that. We're adding security to be able to access the automation, the PLCs more secure. We're adding the reference architectures to be able to connect all the automation PLCs together. Does that kind of answer your question, Jimmy?
Yeah, it does. I'm concerned about, not concerned, I'm looking more at about the API. What type of openness do we have to kind of share, even from a multi-protocol perspective in this environment? Is there anything you can tell us about the API that's on the products?
Sure. So, and Mark alluded to it a little bit in that, so with our partner, Rockwell Automation, we have what Rockwell calls a SIP object on the switch that enables some data tracking as well as some integration and management from the PLC's point of view. So when the plant floor guys, automation engineers, are using the tools that they're comfortable with, that they know for programming and configuring the PLC and the automation side, they can also then use those same tools to access the switches and be able to pull information and actually set some of the parameters and check on open ports and network information, but also build troubleshooting into those automation apps that they have as well.
Nice. That's very good. Now this might be a silly question, so if it is, just go ahead and smack me down, because this is just my own kind of personal question on this stuff. But when you're looking at some of these switch models, in particular when it comes to IoT, how important is local intelligence on these type of things? Seems like to me to be pretty important, but what do you guys say?
Yeah, I was just saying, yeah, absolutely, because the amount of data can be overwhelming, and so having local processing that can figure out what data is important, get rid of the data that isn't needed, but then pass the critical data on either to an operator's HMI or to cloud solutions to run analytics, that's very key. And so the fog concept that Cisco's driving of bringing the cloud to the edge for that local analytics is very key. We also see it in the video cameras for the plant floor, where you have analytics to be able to tell right on the camera if the video image is important or not, because you just can't save everything in a modern factory. I also wanted to address, if I could, Jimmy, just one question that I saw in the chat window that was a really good question, which was, what are the Cisco differentiators? And if you look at the state of the industry a few years ago, where they had maybe Ethernet to the PLC and then proprietary protocols below that, what's different? And I would just say for that one of the things that's changing is you're seeing Ethernet go deeper, right? It's going all the way down to the sensor level and the device level, and that's what is leading to an explosion in new diagnostics data that's possible, where you're not just getting a thin straw of data like, a robot, how many did it build, was it quality, pass, fail, et cetera, but you can actually see the actual real-time torque values and vibration and so forth. That's going to be very important in troubleshooting and diagnostics and predictive maintenance applications or traceability applications for improved quality. That's just one example of what's different. But if you just kind of follow that one through, as you push Ethernet all the way down, suddenly now you need new standards. Suddenly now you're going to have a lot more data, quality of service down at the machine level instead of at the aggregation level becomes important. New security becomes important as well. And, we're working with one automotive customer. They're going to see 10x increase in the number of Ethernet ports in their factories, and that's huge. It could be 30 or 40,000, almost like a data center per factory. And how do you manage IP addressing? How do you do scalability? These are all new challenges that they haven't had before to capture these value props. And that's where Cisco's really shining. Some of the things that Mark talked about, like having NAT in the switch itself versus needing a separate $2,000 box for it, is an example. Or new architectures like what we're calling connected routing that lets us handle much more scalable open automation networks where you can still run the machines reliably, but let data pass through. But anyway, I don't want to take up our remaining time, but I thought that was an excellent question, so I wanted to address that, which is at least a few of our differentiators, plus the architecture, the wireless, the security that we've been talking about.
That is good stuff. That's a humongous investment in brain power, isn't it?
Yeah, just stating that question was a big investment, I think. So it's a different space. It's definitely complex, has a lot of new challenges. But the great thing is with our partners, we've found some really elegant solutions to try to simplify.
Very cool stuff. Well, guys, I think that about wraps it up then. Great presentation. And I want to take a second to thank everybody for coming to the TechWise TV workshop for IoT. Really, really good stuff. Keep a lookout on the cisco.com/go/IoT spot. You're really going to see some pretty amazing developments there for sure as far as products and how we're really going to be, connecting and changing all at the same time. These heavily industrial environments. So it's pretty good stuff. So check it out, cisco.com/go/IoT. Also, if you get a second, click on over to techwisetv.com. We've got some fantastic new assets up there, new shows coming out. We have our Venable Networking 101, as well as our Fundamental series, where we actually animate very different topics. If you're a child of the 80s and grew up on Schoolhouse Rock, you'll certainly get the vibe to it. I promise that Rob and I are not up there singing, although we do have one, but I think we hid that pretty good. So you can definitely check those out, pick up some pretty cool topics as well. And also, if you want to check out any workshops, the TechWise TV workshops are designed to be a companion piece to an episode. So every workshop also is tagged in with an episode as well, where we cover the topic and we are a little more broad in that area, and then we use the workshops to really drill down to the meat and taters of the topic. These are all recorded. We keep them for a couple years, so you can go up there and look at past shows, past workshops, look at the questions that came in, look at the PowerPoint slides we use, all that good stuff. So, heck, you know what? You can even sign up for upcoming workshops we have as well, so you can get an email notification to let you know, hey, Carlson, took time on your calendar because it's workshop time here in a few minutes. So check it out, techwisetv.com, one-stop shopping, all kinds of good stuff. I want to just take a final bit to give a great big thanks to all the folks that presented today, Todd, Bryan, Masamo. Really do appreciate it. Great presentation. Good stuff. And I think that's about it.